In this exercise, we're going to learn how to create a calibration program. What this is going to do is we're going to use a feature called the probe data management. We're going to tell the system what hardware we have as far as our stylus size, what angles we need to calibrate, and then we're going to generate a part program. Okay, there used to be a couple different ways of doing this. They used to have a probe builder icon, which is a macro that did the same thing. Now they've incorporated it in 3.4 R1 into the CMM system manager. Because I'm not sure what software version you're using, I'm going to show you the way that I know is in all the software versions, and it's in the probe data management window. So let's get started. The first thing we're going to do is we're going to select create new program. I'm just going to call it cal exercise and select OK. Now as you can see, it's highlighted in green. There is nothing in this first column, which means there's no program associated with it. If there's a CMM icon, then there's a program. If there's a CMM icon in the second column, that means there's a CAD associated with that program. So I'm going to go into learn mode. Now I could do this one of two ways. I could select learn mode right here, or I could double click in this open space. I am using a laptop computer. I am not hooked up to a CMM. The next step is under the probe window. We're going to select probe data management as seen here. As you can see, I've got a couple styluses already defined. What I need to do is I need to tell the computer what size ruby I have if there's any extensions. So what I'm going to do is I'm going to go over here to the probe builder. And now this window appears. Using the left mouse, I can zoom in. Right mouse, I can rotate. So I'm going to rotate, and then I'm going to use both left and right mouse together and slide it off to the side. As you can see, I have a stylus on here already. It's called the 2x20, and that's the part number for it. Now if I hit the arrow over, it takes it off. Do it again, it's going to remove that module, which is a standard force module, and then this is the TP20 body itself. You cannot remove the head. Alright, most companies don't have more than one probe head on their machine, so they left it so you cannot remove it. Now, the touch probe I'm going to be using is a TP20. So in order to send that over, I simply click it. It shows up in green to give you an idea as to what it's going to look like when it's on there. Until I hit the arrow over, and now it puts it on. Let's zoom back in again. For whatever reason, they keep resetting the screen. Now I'm going to tell it what module I have. I have a standard force, which is the black ring. I'm going to send it over. Bring it back in again so we can see it. As you can see, it has a black collar. There's different colored collars. There's a gray one, which is a medium force, which takes a little bit heavier stylus than the standard force. The biggest one they have as far as weight goes is the extended force. This takes the most. And a light blue ring is the low force module. And it needs to be used with lighter styluses. It has a lower trigger force. Renishaw catalog describes what stylus configurations can go with what module. So I suggest you check it out. Now back over here, as you can see, if there is a length but no diameter, that means it's an extension. For example, if I click the 40, it put a 40 millimeter extension on there. Again, because it's green, it is not added. So I'm going to scroll down until I find 2x20. I'm going to scroll down until I find my stylus, highlight it, and send it over. Now, when you're taking the measurement, it's going to be from the base where it threads in to the center of that ruby is your overall length. And if you have extensions, make sure you put them in there. The other measurement is going to be the ruby size itself. So just get a pair of calipers out, and if you have like a special disc or a barrel, try and match it up. So we are done with this, and if you can change it to 3D front, top, and side view in this window. So we're done building our probe. Okay, so I'm going to say okay. close out of this window. Now, this window comes up and it says delete all the existing probes except probe 1. As you can see over here, I've got a couple more of them. When you would want to do this, I'm going to say yes to this so it deletes them because I want to show you how to define them. But if you have, let's say, 15 to 20 angles that you use on a regular basis that are already in the list, if you say no, it'll update all those with your new stylus configuration. So your choice is to rebuild them all, or to just say no and let it update them all. I'm going to say yes, and then now the next thing we're going to do is we're going to go into define probes. So define probes, it's going to bring up a window here in a moment, and what this is going to allow us to do is determine what angles we need for our cal program. Now, how you know what angles you need is based upon what you need to check on the part. So the smartest thing here to do is to fixture your part the way you're going to measure it. And then if you have a PH10 or a PH10MQ, you should have a small black box, Renishaw, that'll have a digital readout and have A and B positions. You're going to need to close the Mcosmos software out in order for this box to become active, but you can physically hold the buttons down and rotate the head to the positions that you want. It will display the angles in the digital readout, write those down, and then you would go do this exercise. Okay? If you have a manual head on a machine such as an MH20i, simply rotate the head to the different directions, write down the angles. There's two ways to add angles to this. One is you can do it here. Notice graphically, this is rotating as I click it. And again, the rotate, pan, and zoom functions all work in this window. I'm not sure why they default it to -180 instead of 0, but they do. As you can see, it's rotating the B, and it's moving this little blue box around the grid. So once I know what angles I want, I simply click it and I say add. That is one way to add them. The other way, and I'm going to add a 90-90, is to simply double click in the space that I want and it adds it automatically. Now you can remove them if there's one you don't want. You can reorder and sort them. Once you've built all the angles that you want, simply select OK. Now that we've told it what angles we want, we're going to generate the program. All right. You can, if you choose to, select all of them right now and hit the calibrate button and then just follow the prompts. It'll take you through the calibration sequence, but I'm not going to do that yet. All right, I'm going to show that after we get done generating our program. So the next step in the book is to hit the generate part program button. As you can see, all the styluses that I have a check mark by them. If I don't want them to be added to the program, I simply click them. Now it adds it back. The part name needs to be changed. I'm going to describe my stylus with this. I'm going to call it 2x20. And then I am going to give the exact same name to the archive. 2x20. It's kind of important that you do the archive probe. The reason for this is you want to be able to recall your probe data in a new program. Okay. Number of executions 2. I'm going to change it to 1. That's how many times it's going to run it. Probe change distance above is 10 millimeters, meaning it's going to go above the master ball 10 millimeters to change the probe. Number of points per circle is 4. In this particular case, it's going to measure 1 point on top and 4 points around the equator. I can change the angles at which I do that here, and there is disc stylus parameters. If you select manual point on top of spear, this is going to require you to, when you run this program, to physically touch the first point on top of the spear every time. However, if your master ball has been measured in the same spot every time on the table, you can use a defined master ball position. Make sure high precision measurement is checked. Your movement speed is how fast the machine is going to move across the table. Your measurement speed is how fast it's going to move when it takes the measurement itself on the sphere. It is important that the measurement speed in your calibration program be the same in all of your part programs. This is very important. These are mechanical sensing devices. They're spring loaded with the exception of a few different modules or touch probes. The safety distance is how far away from the master ball it's going to be when it executes the measuring speed. You'll notice when you're running a program that it travels fast, then it stops, slows down, and goes into measurement speed. Alright, so once you've done that, I'm going to check this button, and I'm going to select OK. Alright, now that we're done with that, we're simply going to select OK or cancel. It doesn't matter, we want to get out of this screen, and we're going to exit out of this program. We are no longer in learn mode, and because we didn't save anything, notice there's no program. However, there is a CMM program called 2x20. It's the one we just created. So if I open this up in the editor, again, I am running in offline mode. You're probably not going to see that message. You can see I have a program here. And you can change your comment lines if you want. I'm going to exit out of the editor. Now to run that program, all you have to do is double click the CMM icon here. And again, remember, you will be required to manually measure a point on top of the master ball. If you have any questions, feel free to contact me. You can call me anytime. My cell phone number is in the front of the book.